Hello, 7th grade. Welcome. Welcome to the first installment of Learning Math with Mr. Bauman from Mr. Bauman's Basement. So, here we are, my first official visit to the YouTube. Not exactly sure how this is going to work, but I'm going to try my best to make it work. And I hope you're able to follow along and learn a little bit of math in a very unorthodox way. But we're going to make the best of this, and I hope there's a lot of learning that goes on, and have a little fun with it as well. So lots of things have changed since the last time I saw you guys. I hope this message finds you doing well, staying healthy. I hope this finds your family doing well and staying healthy. And we are going to get through this. Believe me, we will. It's just going to take a little bit of time. So my game plan for math class moving forward, and I know some of you were able to join me for a Zoom call a few days ago, but my game plan moving forward looks like this. We're almost done with the 7th grade standards. We really are. I even mentioned that in class last time that we saw each other. We're really down to chapter 10, which was probability, which is, we had started chapter 10 before we left. And so my hope here with these YouTube videos is to finish chapter 10, and we're going to kind of chunk it into different postings, different videos. And once we're done with chapter 10, then I'm really going to kind of review a lot of the highlights from chapter 7 so that you guys are ready to hit the ground running with 8th grade math. It's going to be an exciting time. So we are almost done with the math standards for 7th grade, and this is going to be great. This is going to be great. So we're going to use YouTube videos for more of like the direct instruction, and then I'd like to try to use the Zoom program to do some live video chats where you can jump onto the Zoom call. If you had questions, you were unsure of how to do something with the math, we could use the Zoom platform as more of like a live discussion. Let's just talk about some of the questions or uncertainties that you may have. And we can also use it just to kind of catch up. I haven't seen you guys in a while, and just a chance to kind of catch up and see how things are going, see what you've been up to, what creative things you've been doing at home with your families to pass the time. So again, I hope this finds you doing well. I know this is not what any of us really wanted to happen, expected to happen, but it's our new normal, at least our temporary normal, and we're going to make this work. And I miss you guys a lot, a whole lot, and I wish I wasn't teaching from my basement. I wish I was in our classroom like any other day, but we're going to make this work. And we're going to do the best we can with it, and we're going to learn from each other. So be patient with me. I'll be patient with you, and we're going to get right into this. So obviously I'm not in my classroom. I'm here in our basement, and I don't have a smart board, but I was able to find, in what limited resources we have here at our house, I've got a whiteboard. And I was able to find somehow, I found a brand new pack of dry erase markers, and this fancy thing called a Mr. Clean Magic Eraser. It truly is kind of magical, because this thing was a mess a few minutes ago, and I cleaned it up. And what else do I have? I got my foosball table here. It's kind of serving as my desk. And of course I've got every good teacher has got to have their coffee. A little bit different mug than what you're used to seeing me drink out of. That tastes good. Good old black coffee, even cold, it's good. So, I guess my foosball table also serves as my mug holder. So, I'm going to zoom in here a little bit so you guys can see a little bit better. Again, very much an amateur at this, so bear with me. I also haven't shaven in a couple days, so I apologize for the Grizzly Adams look that I got going on. Let's see if yeah, that'll work, I think. But we're going to make this work. So, let me pull up this screen is what... Oh, by the way, if you need to pause this, if you happen to have your math notebook, if you want to go grab that and a pencil, if you don't have your math notebook, any paper will do. Whether it's a notebook for another subject, whether it's just some scratch paper you found laying around your house, just make sure you earmark it as math notes. This is chapter 10 math notes. So if you need to pause the video to grab some paper, you need a pencil as well. Probably don't need a calculator. If you don't have your calculator at home, you can just use your Google calculator on your Chromebook. But this screen is one of the last things that we had in our notes. I hope that's clear enough. I'm kind of looking at it backwards. But we had this kind of spectrum, kind of gauging or describing the probability or likelihood of events. And by definition, we have that the probability of event is the number that measures the likelihood that an event will occur. And we briefly described, if you remember, gosh, I think it was the last day that we were with each other, we had different pieces of paper kind of taped around the room, and we had 0%, which we called impossible. We had about 25%, which we said was unlikely. Then we had 50% of paper for 50%, equally likely versus unlikely. Then we had one that was around 75%. We used the word likely. And then if it's 100%, that was certain. So probabilities can be measured either as a percent, or they can be measured as a decimal. So if something was 0.75, in other words, we said is likely, it's likely that I will eat some chocolate today. It's not certain, but it's likely. So if I say that's 0.75, I could rewrite that as a percent, 75%. You could even convert it into a fraction if you really wanted to, which would be 3/4. In other words, about 3 out of every 4 days, I'm going to have chocolate because I love chocolate. It's probably much higher than that. To be honest, it's nearly 100% for this guy. So that was one of the last things that we looked at before we left, and I believe for each class, I think the last thing that you wrote down in your notes, and again, if you have your notes, great. If you don't, it's okay. But I believe, I'm trying to pull this up here, one of the things that many of you had in your notes was this formula. Finding the probability of an event. There's a lot of words there. Again, if you want to pause the video and get down the words, the kind of the formalized definition there, that's fine. But really what I'm most concerned with, you having down in your notes, is right here. It's capital P, left parenthesis, event, right parenthesis, equals the number of favorable outcomes, and then a fraction bar, which we all know means divide, that's right, divided by the number of possible outcomes. I'll give you a chance to write that down. P left parenthesis event equals the number of favorable outcomes divided by the number of possible outcomes. So what does that mean? First of all, we use the capital P. Set my computer down on my foosball table, guys. So what does that mean? Let me show you a couple of examples. So let's suppose I had a dice. One dice, which we call a die. That's right, we call it a die. So I had one die. It looks like this. If I want my event, we use capital P to represent probability. So if I want my event, the thing that I want to happen, let's suppose I wanted to roll an even number. I would use this notation. And this is going to start to prepare you for high school. Capital P is used for probability. So if you were to say this to someone, you would say the probability of rolling an even equals, kind of abbreviate what you saw in the definition, favorable divided by total. So that's kind of an abbreviated way to write what you saw in the textbook on my screen just a second ago. The probability of rolling an even is the favorable divided by the total. So if I kind of broke this down a little bit more, probability of rolling even equals even number, the number of even numbers, divided by the total number on the die. That's a lot of words. And in math class, we all know that we don't use a lot of words. We use a lot of variables to represent unknowns, and we use, obviously, numbers to represent the things that we do know. So I'm going to break this down even more. I would say the probability of rolling an even would be how many? So what are the favorable? How many even numbers are there? On a dice, or a die, there's 3. So I would say that there's 3 out of a total of, obviously, 6. Always simplify your fractions. So this would be 1 over 2. We said just a few minutes ago that probability is measured either as a percent or a decimal. Obviously this one's fairly easy one to convert. We would say that I have a 0.5, which is equal to 50%. So the probability of rolling an even is 0.5 or 50%. And using those words that we had on that spectrum that I had up just a few minutes ago, we would say it's equally likely versus unlikely. In other words, it's a 50-50 chance of rolling an even. Kind of like flipping a coin. But what if I changed it? Tell you what, this magic eraser, it's something else. It's worth your money. Let's go the probability. Gosh, what is this thing? I'm intrigued by this. Is this foam? What's so magical about this? I don't know. Guess what this guy's doing this evening, trying to figure out how that thing works. But anyways, let's go. What if we did the probability of rolling a number greater than 4? Probability of rolling a number greater than 4. So this one you got to think a little bit more. Notice I didn't say a number greater than or equal to 4. I just said greater than 4. How many numbers are greater than 4 on one die? There's 2. It's either 5 or 6. So I got a 2 out of 6 chance now. So my probability dropped. Slightly, but it dropped. So probability, I'm going to abbreviate this a little bit. A number bigger than 4 is 1 out of 3. Which, again, we need to change this to a decimal and then convert it into a percent, which is what we did, I don't know, maybe a month or so ago. So this would be 0.33333. A lot of threes. So I'm going to put 0.3 with a repeating bar above it. And if I change this to a percent, move it twice to the right. So this would be 33.3 repeating percent. Which, if you use some of the words that we talked about in that spectrum, we would say that this is fairly unlikely. It gets to a point where you can start using the words like fairly unlikely, relatively unlikely, not very likely. You can start to kind of qualify it using your own Mrs. Trumbull adjectives, or is that adjective? Either adjective or an adverb. That's why I don't teach language arts. I would be the worst. I would be the absolute worst language arts teacher. But you're stuck with me for math, not language arts. All right, what if I said, what's the probability of rolling a 7? How many favorable, so if you go back by definition, how many favorable outcomes are there? Me rolling a 7 on a standard die? There is no 7, so there are no favorable outcomes. So it's 0 out of 6. And we all know that 0 over 6 is 0, which is 0%. And that qualifying word that we use, that descriptor, would be, it's impossible. That's right, it's impossible. It's kind of like me walking to Hawaii. There's 0 favorable outcomes for that. It is literally impossible. The probability of cantaloupes falling from the sky tonight, it's 0. It's a 0% chance of happening. How about probability of rolling, how about rolling a number sorry, it's like a DJ. Rolling a number less than 7 and greater than 0. Should probably change the number and go integer. Rolling an integer less than 7 or greater than 0. How many favorable? There'd be 6 out of 6. That'd be 1. 6 over 6 is 1. Change that to a percent. Move the decimal point over twice. Annex 2 zeros and you get, oh my stars, a 100% chance. In my 43 years of living, I've never seen a die land on its edge. It's gonna roll or fall onto a number, so it is certain that you are going to get a number, an integer bigger than 0, but less than 7. All right, let's move away from the die here for a second. So I raided our crayon drawer, and I've got 5 crayons. We'll call this red, green, white, yellow, and orange. What's the probability of pulling, if I put these in a bag or blindfolded you, and I ask you to kind of blindly draw a crayon, what's the probability of pulling green? There's 1 favorable out of a total of 5 crayons. So that would be 1 out of 5. That's one of those fractions, hopefully, at this point you should be able to do in your head. But if you can't, that's okay. God made us all different. So the probability, if you just want to take these down in your notes, 5 crayons, 5 different colors. The probability of pulling green for us was 1 out of 5. If you used a word, a descriptor, we would say this is relatively unlikely. If you were to blindly draw one of these crayons, 1 out of 5, that's 0.2, by the way. BT dubs, by the way. Move it over twice. Sorry, Lily. and annex 10, that would be 20%. And we would use the descriptor something like unlikely, relatively unlikely, so on and so forth. And the same percent would be for all of the colors. Probability of yellow or yellow would be 1/5, right? 1 out of 5, 20%. What if I had the blindfold on you and I added a 6th crayon? It's hard to hold. Put down my marker. What if I added a 6th crayon? So now I have green, white, red, orange, and now 2 yellows. Does the probability of pulling yellow change? If I only had 5 crayons, it was 20%, right? But if I added a 6th crayon, does the probability of yellow change? Interesting question. Let's do it without the 6th crayon. Let's just go 5 crayons. Probability of yellow was what? That's right, 20%. But when I add in a second yellow, does it change the numerator? Does it change the denominator? Or does it change both? Interesting. Let's write it down. So we would say the probability of yellow, this time with 6 crayons. So the denominator does change. Now the denominator is 6. How about the numerator? What would the numerator be? It'd be 2. So it would also change. So how does 2/6 compare to 1/5? Try it without a calculator to start off. Pause the video if you need to. How does 1/5 compare to 2/6? Is it bigger? Did my chances go up? Did the probability go up? Or did it go down? Or did it stay the same? Always reduce your fractions. Put the crayons down here. Always reduce the fractions. So now we have 1/3. We've already done 1/3 actually. That was 0.3 repeating, which was 33.3 repeating percent. So the answer is your probability went up when you added a yellow. Some would say, well, it didn't rise too much, but it definitely went up. If you're blindly picking crayons from this bag, the probability of picking yellow definitely went up when you added the crayon. Even though the number of crayons went up, the probability rose as well. Alright, so let's do this. How about, let's go back to the crayons again. We said the probability of picking yellow was 2 out of 6. What if I had a whole bucket of crayons? And let's suppose that the same colors existed in those buckets. And I told you that the increase in the number of crayons was proportional. What if I had 120 crayons in the bucket, and the crayons that I added were only yellow, green, white, orange, and red, but they remain proportional to the original 6 crayons. So here's my original 6, 2 yellows, red, orange, green, and white, but now I have 120 crayons. How many yellows do you think I now have in my big bucket of crayons? Pause the video right now, and we're going to try to figure this out individually first. I'm going to do it on my board, you try it on your board, and we'll come back together here in about 30 seconds. Go ahead and pause the video. I'm going to work. Alright, welcome back. I didn't pause mine, but hopefully you paused yours. Anytime you got a little bit tougher problem, you know what always helps? Coffee. Still good. There we go. Alright, so what'd you do? Curious. I can tell you there's not just one strategy that you could use to come up with the number of yellow crayons if you had 120 in this bucket. I wonder, and this is one moment of many that I wish we were in class right now so I could just ask for a show of hands. How many of you chose to run with the percent? Interesting. I bet some of you are like, yeah, I just did 33.3% of the 120 crayons and I got my answer. Perfect. How many of you ran with the decimal? I would say some of you probably ran with the decimal. Again, 0.333333333 times the 120. And you should have gotten the same answer. How about how many of you kind of ran with the fraction? Probably some of you. How many of you did a proportion? I kept using the word proportion over and over again. How many of you set up a proportion? That's what this guy did. That's not the only way to do it. Lots of different ways to run with this. So you could have taken 33.3 repeating percent times the 120, should get the answer. You could have taken 0.33333333333 times 120, still should get the same answer. Or you could set up a proportion. So I knew that 2 crayons were yellow out of the original 6. My question was, how many crayons are yellow out of the 120? How do we solve this proportion? This is why we did what we did back in like January and February, cross multiply to solve the proportion. So if you could, go ahead and write down this proportion. Go ahead and pause the video if you need to. Write down that proportion. Let's solve it. Cross one way, I get 6x equals 240. What do we need to do to both sides to get x by itself? That's right, undo the multiplication. That's why we did what we did last fall. Divide by 6. 6's cancel, and we get x is equal to 40 yellow crayons. Let me go ahead and label that. $240, and I'm reading backwards. That's a 6. Mine looks like a 2, but that's 240 divided by 6 is 40 yellow crayons. And how can we check it? Well, again, you could take 0.3333333 times 120, and you would still get, you should get 40 crayons. Or the same thing with the percent. I'm looking for my eraser. There it is. Well, DJ dropping G's. That's right. Oh my goodness. I didn't know I could have so much fun doing math sitting in my basement with a magic eraser. It's magical. All right, let me get back on my computer. We're about done. I hope you're still awake. Hope I haven't bored you into a nap. Try my best here. Let's see here. Stay awake for about one more problem here. Alright, I'm just going to hold up the screen because that's what I'm going to do. Alright, similar problem. If you need to pause the video to write this down, just paraphrase it. You don't have to write every single word, but get the most important ones down. The probability that you randomly draw a short straw from a group. Again, I'm reading backwards here, so bear with me. It looks like grog from my vantage point, but I think that says group. Probability that you randomly draw a short straw from a group of 50 straws is 9/25. How many are short straws? Go ahead and pause the video. Similar problem. Interesting. Again, I wish I could do like a real quick survey here. How many of you would keep this as a fraction? How many of you would first convert the 9/25 into a decimal or even a percent? The answer is it doesn't matter, because 9/25 can be converted into a decimal of equal value or a percent of equal value. How many of you would set up a proportion? Interesting. Go ahead and pause the video. I'm going to solve mine. You solve yours, and let's see if we get the same thing on the back side. So go ahead and pause your video. I'm going to go ahead and start working. Stay awake for about 5 more minutes. We're almost there. In the words of John Bon Jovi, we are way past halfway there. And I have yet to draw on myself yet, so it's been a successful lesson. All right, let's go and come back together here. Put this computer up on my desk. There we go. All right, show of hands. Who used the decimal? All right, who used the percent? And who set up a proportion? Interesting. I would say at this point, probably most of you did a proportion. And that's quite all right. You should get the same answers as the other folks. If you decided to use a decimal, I got 0.36. I don't have a calculator down here, but I'm pretty sure that's 0.36. What word could you use? It's definitely not equally likely versus unlikely. It's relatively unlikely, but a stronger probability than some of the other ones we've talked about in that 0.33 or even lower 0.2 range. Definitely a little bit stronger possibility. 36%. But I imagine most of you probably set up a proportion like this. 9/25 is the number of short straws out of the original group of 25 is equal to some number of short straws out of 50. Many of you, I'm guessing, probably recognize that you could just multiply this by 2, which would multiply this by 2, which means M is equal to 18 short straws. Or you could have cross-multiplied 25M equals 50 times 9, that's 450. Divide by 25. And there's 18 groups of 25 in 450. So whether you recognize the multiply by 2 on the top and bottom, by the way, why is that allowed? 2 over 2 is just 1. Multiplying by 1 doesn't change the value of anything. But if you didn't, you could have cross-multiplied and still have obtained 18, let's just call it SS, for short straws. So that's pretty much the end of this section. 10.2. Let me pull this back up. Now here's the thing. I don't know how many of you happen to have your hardcover book. And I'm hoping that all of you have your Chromebook. Certainly hope you have that with you. And if you don't, hopefully someone in your house has a device that you could use all of you have been completing the assignments via IXL, so I know you have at least some device at your house. But I'm going to steer away from using the textbook for the form of assessment for each of these lessons, but I'm hoping to utilize a little bit more of Google Classroom. So here's what I'm going to do. I'm going to post a couple of questions on Google Classroom. The first part of this week, when you see this video, it should be the week before spring break. So I'm going to post a couple questions on Google Classroom, so be checking that, and they will all be related to what we just did today. So if you were not able to join us for the Zoom call in the last couple of days, that's what I really kind of talked about. So I'm going to try to do less IXL, less Khan Academy, because I know listening to Sal and doing IXL is not the most exciting thing to do. So that's why I decided to try to upload some YouTube videos, allow you to get some instruction via my basement, and then utilize Google Classroom with 2 or 3 questions, 4 or 5 questions each day as a way to really assess whether or not you now know more about probability than you did at the beginning of this video. So that's kind of the way I foresee things kind of unfolding over the next couple weeks while we are away. Hopefully I'll see you on May 1st in person, and we're just going to get right back into it and hit the ground running. But in the meantime, this will be kind of the means of communication with you for instruction. I hope to do an assignment or YouTube video about every other day in the weeks to come. So if you don't see a video or an email from me every day, that's okay, because I'm shooting for every other day. I know you got a lot on your table, school work and other things. It's starting to get a little bit nicer outside. Go outside, get some fresh air, go take a walk, shoot some hoops, go throw a football, frisbee. Climb a tree, do whatever you need to do to be active, but definitely get some fresh air. And then we'll try to utilize Zoom maybe once a week. Again, it's kind of just a chance to kind of connect face to face, but also a chance to kind of get caught up on how things have been going, and also a chance for you to ask questions on any of the assignments from that week. So I'm going to, again, kind of summarize. About every other day you're going to see a video and or an assignment. We're going to utilize YouTube as the direct instruction, less IXL, less Khan Academy, and you'll see your questions, your homework will be on Google Classroom. All right, I think that's about it. Again, I hope this video finds you all doing well, making the best, finding the silver lining in everything that we've been through here in the last week, and above all, be kind to one another, especially your family. They love you very much. I love you very much. I miss you guys a whole lot, and I wish I hope this time goes very quickly, and that we're back together face to face very, very soon. So be kind to one another. Be patient with one another. I know we all got a lot going on, so be patient. Extra dose of patience goes a long way. And above all, make sure you pray. I think that's the perfect source of peace right now, and I think that's exactly what everyone needs, is more peace, peace of mind, peace of heart. And so pray. Pray early, pray often, pray regularly, pray with your family, and we are going to get through this together. I miss you. We love you, and I hope you learned a little bit about probability today. And until next time, I'll try to find a different space in the basement, so you got a different backdrop every time. Until next time, be well, be safe, and be patient with each other, and don't forget to pray. All right, see you guys.